Hello everybody, welcome to my channel. Today we have a very good problem for you guys that's called sum root to leaf numbers. So this is a very good problem. It's actually a very classic problem, right? It's a classic. So let's quickly go ahead and read the prompt statement, right? So it says we're given a root of a boundary tree, right, containing the digits from 0 to 9 only, right? So each root to leaf path in the tree represents a number. For example, the root to leaf path 1, 2, 3 represents the number 123, right? So so return the total sum of all root to leaf numbers. So it says test cases are generated, so it's just that the answer will fit in a 32-bit integer. So it's a very good thing that they're telling us that, right? So a leaf node is a node with no children. So very good. Okay. So our job, right? So the task here is to, for each path, right, from that starts from the root to a leaf node, right, those numbers, those digits along that path, right, form a particular number, right? For example, this path 1, 2, right, that's a leaf node, and so that's a path from root to leaf. So that path, right, the digits included along that path, right, starting 1, 2, the root first, and then the second one, the last leaf node, right? 1, 2 equals that number represents is 12, right? So we do 12, and we do the same thing here, 13, right? Because that's another path. That's why we have 12 plus 13 equals 25, right? That's exactly what they're saying. So that path 1, 2 represents the number 12, right? You know, so they're saying that each node will have a value of 0 to 9 only, right? So we don't have to worry about, you know, right? So each node will be like a digit essentially. So the second example is kind of very similar. So this one we have a couple more. We have 3 numbers that we can have, right? Because we have three leaf nodes, right? 3 leaves. So we have 495, which is the path 495, and then we have another one 491, which is 491, right? And then we have 40, right? Which represent that. So 495 plus 491 plus 40 gives you 1026. So this is kind of what it is, right? You know, it's kind of what the ask is, guys, right? So our job, right, is to come up with an algorithm, right, to solve this, you know, in the best way possible, right? So how can we go about it, right? No, so normally we like to start off with a very simple approach, not trying to be overly smart or slick in any way, right? We want to solve it with intuition, right? So the quickest way I can think of, right, you know, as I'm visiting the node, right, just add the numbers, right, add the digits to, so how do I represent it, right? You know, can I do 1 plus 2 and somehow equals to 12? No, that's not gonna work out, right? So we need the representations of each of the nodes, right, as we go along those paths, guys, right? It's kind of the thing that we need to solve. So how do we solve this, right? Okay, so maybe I can represent so as I go along, right, how can I easily append to the next number, right? Because that's what I want, right? So I could have a string, I'm thinking, right? String can help to solve this problem that I'm having, right? So I have a string, start off with an empty string, right? Then I visit the root node, and I add 1 to it. And then for my children, right, I passed in myself, right? I passed in a 1, right, into a string of 1, right, to 2, right, and then 2 just appends itself as well, right, and sees that now the string will be equal to 12, right, 1, 2, and at the end, right, so once we encounter a node, right, that's we encounter a node that's you know, a leaf node, right, then we go ahead and say, all right, cool, that string that you have right now, right, that you're currently building, because we're building the string as we go along, right? The current string that we have now, what's the value of it, right? So we do a parse int, right, to parse the string, and that would give us, you know, the number that it represents, right? So it would be 12. Cool. We add 12, and then we return that to the thing, right? So from the left side, those are the sums, and was able to get and then it goes also does the same thing on the right side, passes in its string, and then 3 adds itself to the string, right? 13, and then it returns 13 to this, right? And then 1 has all the answer from the left side and the right side, the integer values, right? So it has 12 from the left side and 13 from the right side, right? Those are the numbers that were able to form using that the root node, right? So we have 12 plus 13 equals 25, right? And the same thing will happen here, guys, right? So we have start with 4, we add 9 to the string. Now we have the string will literally be something like that, guys, right? 4, 9, once we get to 9, right? And then now 9, right, it's gonna pass in 49 to 5, right? And then 5 is simply going to append itself, right? Then we have 495, and then we do a parse int, right? And that would give us the particular value, right, of 495, which is the integer that we need, right? Then we will add it to the result, and then do the same thing here. 491 does the same thing. Then returns itself to this guy, okay? And then in this guy, just say, cool, just award the sums that we were able to form, right? And sends that to the root, right? And the root goes to the right side as well. It does the exact same thing, right? It returns to the caller, right? That's how we're able to get to 1026, right? So it's not a very, very bad thing, right? But you know, passing the strings back and forth, right? It's not gonna be very efficient, guys. So we need to come up with a better approach to kind of solve this in a best possible way, right? Because strings, guys, are immutable, especially in Java or in some of the languages, right? You know, so the memory allocation can get very, very high, right? Because we're doing a lot of, you know, passing of the strings. A new strings gets created, and it's not very, very good, right? But you know, it's technically time complexity is good, you know, but the memory, right? You know, we have to be a little bit more efficient, right? When I switch our thinking a little bit, right? So this is why I'm going to bring this to my whiteboard, so you can kind of quickly come up with a more efficient. So now the alternative approach that I was referring to, right, is instead of treating every digit as characters, right, in a string, right? How about we treat them as a number instead, right? You know, as we go along, we could build the number, right, accordingly as we go through. Because the issue that we're having, we can't simply just naively just add the numbers up, right? You know, we see 4, then we add 49, and somehow we add plus 5, right? And it's equal to the integer value of 495, right? That simple would not work. So we need to convert the numbers as we go along, right? Somehow, right? So we see 4, right? We need to shift 4 to the left, right? So that it's the place that it goes in, right, is more significant, right? You know, so instead of being a 4, and which is in the 4, right? Now it becomes in the tens place, right? The tens place now it becomes 49 when it goes to 9, right? And then just like it goes to the 100th place, right? Right. So we need to make 4 look more significant, right? So this is how we're gonna talk about it now. All right. So the mechanic of shifting the numbers, right? Because I told you that. So initially we start off with 4, right? So 4 is the root, okay? And then once we have another number, right? Say we have the 9 that we want to add, right? And we want to shift the 4 to go into a more significant place, right? The 10th place, right? So it initially was in the 1st place, and it needs to go to the 10th place, right? So we need to multiply it by 10, right? And then add whatever number to it, right? So the formula is just like that, right? So we start off with 0, and then we do 0 times 10, right? Plus 4, and now it's in the 1's place. Once we go to 9, right? We see 9, we do 4 times 10, which is the, right? This is how we simulate moving it to the left, right? To go to more significant spot, right? So 4 times 10 gives you 40 plus 9 gives 49, right? So this is what, right? Then once we get to leaf node, we build it again, right? 49 times 10, and then add the 5 to it, right? And notice that we can do the appending instead of using a string to append numbers, right? We use this particular technique, right? This is a very classic technique to really master, because it's using a lot of different problems where you have to deal with digits and you have to shift the numbers, right? You know, and build the numbers as you go along, as you see characters, right? You know, so it's a very good, important to have, right? So you see, you can kind of visualize this a little bit better. You see, we have a 1's place, and then we want to shift whatever number to the 10th place, right? So we can add another number at the end, right? We multiply that current number by 10, and then we add that. We literally just add like a plus sign, right, to the number, right? And then we see 49. If we want to add another place, we get the 49. We times it by 10, so everything could move. The 4 could go to the hundreds, and the 9 could move to the 10s, right? And then we add that number, and we keep doing that over and over, guys, right? It's kind of the mindset here. So to help you guys to visually see it, right, is that we have a 40, well, we have 0 times 10 plus 4, right? See, it starts, because the current number is 0, right? There's nothing there, so that's why it's 0. So we do 0 times 10 plus 4, it gives you 4. Now it's in the 1's place. And then we go to 9, we do 4 times 10 plus 9 gives you 49. And then we have, once we get to the 5, right, we do the same thing. We do 49 times 10 plus the 5, we append the 5, and we reach a leaf node. Then we go ahead and return 495 to the caller, right? Because that's leaf node, that's the caller's 9, and we return it to it, right? And that's kind of how we do it, essentially, right? At each step, right? We build the number and we pass those numbers to our children, right? So it's kind of the main gist of the thing, right? So you just going in more detail. So you see just the same thing, 40 times this, and pass 9 passes 49 to the right side as well. We do 49 times 10 plus 1, right? Add that digit. So we move times it by 10 to move everything to the left. So we could have space to add that number, right? So it's kind of the main gist of it. So that's how we end up doing the whole thing, right? Every time we reach a leaf node, we just add it to the current number that we're building, right? So it's now we've switched our approach from building a string to just build a number as we go along. That's kind of how we reduce our memory footprint, right? We kind of reduce the memory thing that we're using. Okay, so now that we understood the solution of hopefully by now, let's quickly go ahead and code that up. I think it'll make a lot more sense for you guys. Okay, so what we're going to do is just to have a helper function, right? Helper root, right? So that's in the root. Okay, and we also need to pass in so initialize 0, guys, right? Initially 0. Okay, but now we're going to have our function. So now it's going to be tree node. We're going to pass in the current number that we were building, right? Okay, so if the root, the node that we're on is LeetCode null, right? We return 0 because to return to the color, right? It's 0, right? It's a null node. We have to put an integer. Okay, so now we're going to do a check, right? If the node that we're on right now is a leaf node, okay? So if the left side is null and the right side is also null. Okay, if that's the case, then what I'm going to do is to return the current number that I'm on, right? The current number that I have, that I've been able to build along that path, right? Remember, we're building it as we go. So now, so we're going to return, right? So we need to also print the current node that we're on, because we're doing the check here, return current number, right? And if we do it after, it wouldn't include that leaf node in there, right? So what we're going to do is to just build the current number, right? First thing we do every time we get into a function, right? So the current number, we use the exact formula that I told you guys about, which is the current number that we're on, current number that we have so far, times it by 10. We must think a bit of shifting it to the left so that it can make space to add the number, right, which is the least significant number, right, which is to the right side, right? So this is kind of how you need to kind of think about it. Okay, so it could be at the least significant, so at the ones place, right? So now we just add that node value, right? Node that val. Okay. So after we do that, okay, so let's say if it's not a leaf node, then we also need to visit our left side. Okay, our left side will be by passing in the node that left. We'll also pass in, right, the current number that we've been able to build so far. Okay, and then we end up doing the same thing to the right side. So instead of calling it left, we call it right, and we also pass in our right side. Okay, we also pass in the current number, and after we do that, we return the left sum, right, also the right sum to our caller. Okay, everything looks good to me. So we started off with the current number equal to 0 initially, and then we build the number at each time we visit a node. All right, and then we check if it's a leaf node, then we return that number that we were able to build, right, so far along that path. And the left side, we go left and we go right, and we return both of those answers here. All right, and then yeah, it looks good to me. It looks like everything passed. So the key takeaway here is this one is building the numbers as we go along and moving things to the left so we can add stuff to the least significant spot, right? You know, so we have space for it. So it's kind of the main gist. So if you guys understood the thought process, and press submit if we're in good shape. It looks amazing. We beat 100% of the submissions, right? So if you guys like the problem, right? You guys understood everything in the comment section. If you guys are new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.